This episode is brought to you by the all-new NAD M10 V2. Imbued with the renowned amplification expertise of NAD, the M10 V2 combines audiophile nuance with state-of-the-art high-res multi-room functionality to deliver an incredible listening experience.
Welcome back, everybody, to another episode of the Darko Audio Podcast. With me this time out, it's not Michael Livornia, it's not Srajan Ibayan, it's one Rob Watts from, I guess we could say, Chord Electronics, Rob?
Yes, you could.
Right?
even though I'm not employed by Chord, I'm independent.
Right. But you do a lot of their DAC development work, right?
Absolutely.
And we have a new DAC to talk about today. It's the Mojo 2. Did COVID accelerate this project?
No, it actually did the opposite because of problems in getting hold of parts and all that kind of stuff. So the project itself started as a design project in 2018. So it's 4 years old.
Right. That's a long time to be working on something.
Yeah, we actually got through 5 different versions of the design. That's PCB design, not the coding design. And some of the benefits of it being much longer than we expected meant that I could do more improvements to it.
So I guess we should talk about the obvious things, right? It's the same size as the original Mojo. It still has the, what do you call it, polychromatic buttons. But there's now an extra one, which is a menu button, right? So they're a bit smaller. Yes,
that's correct.
Right. Yeah. And then there's a USB-C port tucked away on the almost the underside of the left of that sort of digital connectivity panel.
That's right.
Am I correct in saying that you had to do it that way, put the USB-C there so that the poly would still connect as before?
Yeah, the design brief for the project was that it must be compatible with poly. What we didn't want to do was to have all those thousands of users of poly to be upset that they couldn't upgrade. So it needed to work with poly.
Right.
The original design brief was that there would be 2 USB-C ports, one for the charging and one for the data. But it was just such a squeeze. The trouble with USB-C connectors is they're actually physically very long. And the one that I was going to put in for the charging port conflicted with the optical, which meant dropping the optical, and I wasn't prepared to do that. So we're just left with a 1 USB-C.
Right. I use Toslink quite a bit. So I'm glad you didn't drop the optical connection.
No, there's no way that was going to happen.
Right. And is the reason that the coaxial input being a 3.5 mil sort of headphone type socket, is that because of the lack of internal real estate, the squeeze inside?
Yeah, exactly. And of course, that's what we did on the original Hugos and Mojos anyway. The nice thing about 3.5 millimeter is it is a very small connector.
Yeah, I guess it's just a little bit of an extra fiddle for end users to find the right cable. I've had 2 made for me. But yeah, it's not the end of the world or anything like that. I guess, one thing I did notice somewhere in the press materials for the Mojo 2, I'm going to leap straight to this if you don't mind, is that I noticed that the coaxial input is specified as being capable of accepting signals up to 768 kilohertz.
Sure.
Why?
Why is that? So that you can run it with the M scaler.
Really?
And it's as simple as that. We had a few people saying that they like to run it with M scalers. When I use my Hugo 2 on planes, I always carry an M scaler with me. And use a battery power bank to power the device, and run the 2 on the plane that way. I think it's pretty unlikely that someone's going to be using an M scaler, the Hugo M scaler with it. but we don't know where we're going to be in 4 or 5 years' time. Perhaps FPGAs may suddenly get a lot better, and with in the case of a Mojo type scaler, it would have to be a lot better, and it's not going to take 5 years. It's probably more like 10 years. But you can certainly see in the future the possibilities of M scalers coming down in power and in cost, and allowing it to work with something of that size. So it would be silly not to have that support. And when I actually did my listening tests with the product, it was done with the M scaler, so that I get the best possible input source to do all the listening tests.
That is interesting. So you got this big honking great M scaler, and then you've got a tiny Mojo 2.
Yeah.
All right, but that's, I mean, I guess we would probably classify that as an edge case, maybe. I don't want to be too... Right, okay.
Absolutely. Very much so.
Most people are going to be using USB, TOS-Link, straight from computers and phones as well, because let's not forget when the Mojo was first launched, it was very much targeted at phone users, although I think John Franks has gone on to say that he was surprised by the number of people that used the original Mojo in hi-fi systems. I'm one of them.
Yeah.
I guess we should talk about the DA converter, because this thing is a headphone amp and a DA converter. It's not your average DA converter, is it, Rob?
Absolutely.
Right. Can you explain to people who might not be across what you've done inside in terms of DA conversion, how the Mojo 2 and the Mojo, I guess by association, differs from, I guess, your run-of-the-mill DACs?
Well, there are three important issues with my DACs that are completely different to all other DACs. The first one is small signal accuracy and resolution, and that's very important from the perception of depth and details. The other important thing, which is very measurable, is the lack of no noise floor modulation. And we can see this on the measurements that we plot. You'll see on other DACs huge levels of noise floor modulation. Now, by noise floor modulation, what I mean by that is that when you listen to a DAC and you're playing a very quiet piece of music, you'll have a certain level of noise with that. And that's technically known as the dynamic range. As you increase the signal level, the noise increases. And that increase in noise is called noise floor modulation. The trouble is the brain is incredibly sensitive to noise floor modulation because it cannot differentiate between the sound of the instruments and the sound of the noise pumping up and down with the instruments. And that makes this noise, which is bright, makes the thing sound artificially bright. Another thing that happens is that you've got a noise that's pumping up and down, but it's pumping up and down with all of the instruments. And that then makes it more difficult for the brain to separate individual instruments out into individual entities. So you lose the ability to perceive different instruments, as well as it's screwing up the ability to perceive the timbre correctly of the instruments. These things sound artificially brighter and more aggressive. I mean, we can see this on all my DACs, including Mojo 2 and the original Mojo. There's no measurable noise floor modulation. All other DACs have significant levels of measurable noise floor modulation, which is one reason why no one actually publishes these plots, because it would show how awful they actually are. The third thing, and this is probably the most important thing that separates the DACs from other DACs, is the reproduction of transients. In terms of reproduction of transients, their timing. This is the WTA filter. In terms of the M scaler, we're looking at 1 million taps. In terms of Mojo 2, we're looking at 40,000 taps. That's relatively a huge amount of processing going on. In the case of Mojo 2, we've got 40 DSP cores per channel doing the processing. And what this means is that the transients, the timing of the transients, are being much more accurately reproduced. The problem we have with digital is that we have one sample, and then 22 microseconds later, we have another sample. The problem is the brain needs to know what's going on between one point and the next point. And all conventional filters have problems in working out what was going on between one sample and the next sample. And this means that transients are either slightly too early or slightly too late, and they're constantly being modulated by instruments in the past and in the future. And this modulation blurs the transients. Perceptually, what that changes is the ability to perceive pitch, particularly bass. It changes your ability to perceive timbre variation, and it changes instrument separation and focus, because all the transients are being modulated by one another, by other instruments. And that, again, confuses the brain, and the brain can't actually separate individual instruments out. So those are the three major factors that differentiate a Chord DAC from all other DACs.
But you don't use off-the-shelf DAC chips, do you?
No.
Right, you sort of design your own from scratch, really, don't you?
Exactly, yeah. So I've got control of everything from the digital inputs right through the digital chain, through to the analog and the outputs. And those three factors that I talked about, you can only do that when you have control over all the different elements.
Right. So correct me if I've got this wrong. Basically, you've got an FPGA, and then you code it as you want to with your W2TA filter plus other things, and that handles the DA conversion, right?
Yeah. Plus there's another important fact. The FPGA is a digital chip. It's not an analog chip. So the conversion from analog is via discrete components. So they're individual flip-flops, individual reference supplies, and resistors. The benefit of using discrete conversion is that you can separate noise from the digital processing from the analog. And it also means that you can get extremely low levels of distortion. And it's the only way that you can eliminate this measurable noise floor problem, by keeping the two domains completely separate.
Right. Interesting. I didn't know that. So is it fair to say that the filter you've put in the Mojo 2 is a big step up from the Mojo 1, or is it more of a sort of evolutionary development?
No, it's more of an evolutionary thing. It's not a huge change.
Right.
I think the original Mojo was 38,000 taps, so it's gone up by a little bit. I've also improved the filter itself and brought it up to the common standards in terms of the internal architecture. But this is pretty small scale stuff. It's just subtle improvements. Right.
And then I guess the other part, well, the way I perceive it anyway, and maybe you can correct me if I'm wrong here, the other big part of of the Mojo 2 and the Mojo as well, is the headphone output, right? Yes. I mean, because once you've converted to analog, then you have to drive a headphone or an input on a integrated amp or something like that. Now, have you made any changes on the sort of analog side?
There have been a major change, and that was regarding the power supply. The analog electronics, the amplification, the headphone drive, all of that is pretty much identical. Slightly improved layouts, slightly improved things. There's nothing to talk about there that's significant. But the big thing was the power supply. So what I wanted to do was to be able to have Mojo 2 run without the battery. The original Mojo required the battery to be there to get the best sound quality because of low impedance and reducing noise that's from the power supply feeding back into the amplifier, and that creates a level of distortion. So I had to do two things. One was to improve the charging power supply, so that when you run without the battery, the charge current was there for dynamic currents. And I had to improve the power supply rejection ratio by putting in separate regulation, so that the effect of the low impedance battery wasn't there anymore, and so you'd be able to run without the low impedance battery. So I actually ended up with much better performance, even with the battery being added. So I guess I'm kind of jumping ahead of myself, really, because one of the modes that we've got with it is an intelligent desktop mode. So when you plug the battery in and charge it up and it's running, once the battery is fully charged, it actually gets physically disconnected.
Okay.
So the benefit of that is you can run it for 3 or 4 years, and the thing has only been charged once, and the battery is actually physically disconnected. So you don't get any battery wearing out. What we did find with Mojo 1 was a lot of people were using it in desktop situations.
Right.
And of course, the battery in a desktop is constantly being trickle charged, and it's constantly wearing out. Whereas this situation, when you're running it in desktop mode, the battery is out of the picture. The downside to that, of course, is that you've got the benefits of the battery operation. You then have to work a lot harder in terms of the power supply and in terms of the power supply rejection ratio to replace the battery that's been disconnected. And that's what I've done with it.
I see. So could end users of Mojo 2 expect to hear an improvement in sound by running it in intelligent desktop mode?
You're not going to get an improvement, but you're not going to get a loss. It's about maintaining the quality. You're always going to get a slight loss by physically connecting something to the mains via the charger, and you can't avoid that. You're always going to get the best sound quality by having it purely battery. What I wanted to do was to make sure that drop in performance was minimized when you're running it in desktop mode.
Gotcha. Now, I have noticed that there is no longer the line level startup on Mojo 2 that was on Mojo 1.
Yes. Well, that was for 2 reasons. One reason was that a lot of people forgot about the startup, changed the volume, and then powered it up again and plugged their IEMs in and blew their ears out. So we had a few people doing that.
Really?
The other, yeah. Oh. I mean, they didn't literally blow their ears out, but they did they did hurt themselves.
Yeah.
So that's one issue. The other issue is that we've got this DSP and the tone controls and the EQ, and there are more setup options within the device. And I need to simplify things so that it was as simple as possible. The third factor, I suppose, is that we found that since Mojo, with the 3 volts coming out, a lot of amplifiers won't tolerate 3 volts, and it's a little bit too much. So that's why on the Q test, I had the 1 volt, the 2 volt, and the 3 volt settings so that people could tune it to suit different preamplifiers. So if you're going to run it with different preamplifiers and you want to get the best sound quality, then you just adjust the volume control to suit that preamplifier and then just leave it set to that level.
Is there a color code for unity gain, or is there a color code for a certain number of volts? I mean, when I say color code, I mean on the volume buttons.
Yes, there is. And I actually published it on the presentation that I've put together for Mojo 2. So you can see on what the actual colors mean in terms of voltage.
Okay, so I guess we should talk about what I perceive is to be like a very significant change in Mojo 2, and that's the DSP functionality that you've built in. Now, before we get to what that is, I mean, basically there's crossfeed and EQ. Before we get to that, I noticed the press materials are pushing this as the world's first lossless DSP.
Yes.
Right. Now, I'm trying not to be a bit of a dick in asking this, but does this mean that all other DSPs are in some way lossy?
Yes.
Oh, okay.
So I ought to explain what I mean by lossy, because of course the EQ is changing the signal. It's not bit perfect. by definition, because you want to change the signal itself. The problem with 64-bit processing is 64-bit floating point from your PC is that it's not good enough to do EQ. And you can do this as a listening test if you get a graphic equalizer and set all the settings to plus 1 dB, and then change your volume control down by minus 1 dB. Listen to it and compare it to when you've got no DSP, no EQ, and your volume is back down to the original. You hear quite a big change in the sound quality, even though the frequency response is now flat with the EQ. Things sound harder and brighter and more aggressive. Just your sense of detail resolution and depth is compressed. And it's quite noticeable when you try that. The reasons for that is that 64-bit uses floating point. Floating point arithmetic, by its very nature, creates noise floor modulation. The noise floor modulation is actually very low, but it's very, very audible. You can actually hear it. And that's the reason for why conventional DSPs sound brighter and more aggressive. The other factor is that the small signal accuracy is being degraded. And one of the things that this has really came about with the development of Dave. What I've discovered with Dave was that my noise shapers, as I improved the noise shapers, the quality of the sound quality in terms of depth and detail resolution got better. And I started off using we're going back to now 2014. In those days, I thought 200 dB performance noise shapers was perfect, because why would you need more than 200 dBs worth of performance? Because no one can hear at minus 200 dB. But what I found was that as I improved, the noise shaper went from 220 dB, the perception of depth got better, and then went to 240 dB. Again, the perception of depth got better. Eventually, I went to, with Dave, 350 dB performance on my noise shapers. And again, even going from 330 dB to 350 dB, you could hear an improvement in depth. The problem with this was that if you use a very, very small signal, and I actually use, for my test work, minus 301 dB as a signal, and look at the amplitude of that, the noise shaper will degrade the amplitude, so that as the signal gets smaller and smaller and smaller, it can't reproduce and resolve it. So the level of the minus 301 dB becomes much, much smaller than the minus 301. In fact, if you look at a conventional DAC using a normal chip, they're looking at noise shapers of minus 140 dB. So they cannot reproduce signals below minus 140 dB. It just gets completely lost. And here I am worrying about minus 301 dB. Now, the issue with DSP is that when you're doing EQ, you still have this problem. And it's even worse when you're doing something with DSP, because you multiply the signal with a coefficient. And if you're trying to do bass EQ, for example, the value of that coefficient is very, very small. Then it gets added to itself, and it does that thousands of times over. So you've got a very severely attenuated signal, which is then magnified up within the DSP process. And that small error then becomes a very large error. So when I then applied what I knew about DSP, the requirement for being able to reproduce minus 301 dB, if you look at conventional DSPs, they're completely incapable of resolving those small signals. And that's the reason for why you get a degradation in the perception of depth and detail resolution. There's another factor as well, and that's the phase shift. Mm-hmm. So when you have a filter, it will have a phase shift. And one of the things I discovered, about 2 or 3 years ago, quite recently, was that that phase shift, if it changes with amplitude, you can hear it and you perceive it in terms of suppression of depth again. And this came about because of the M scaler and trying to understand why a million taps has got so much better depth. It sounds like a cavernous soundstage, comparing it to, say, 164,000 taps on the Dave, for example. And it turned out to be the problem was phase accuracy. And what you've got with DSP is that as the signal gets smaller and smaller and smaller, the filter stops working because it cannot resolve the signal. So very, very small signals will have a different phase angle to very large signals. And again, this has now become one of my formal tests. If I put in a 0 dB signal, I measure the phase shift, I put in a minus 301 dB signal, and I again measure the phase shift. And if there's a difference, we're in trouble. And from listening tests, I know if the difference is as much as 0.002 of a degree, you will still hear it. And you'll hear it in terms of suppression of depth.
Really? Such a small amount? Well,
such a small amount. Right. I mean, one of the benefits, or the only benefit of COVID, is I've been spending a lot of time doing a lot of listening tests and a lot of research, and with time on my hands. And I've been finding out some incredibly sensitive things going on, really crazy levels of how small particular things are, that they are very, very audible. So when I came to design the DSP, I knew that I had to be able to reproduce minus 301 dB, perfect in phase and perfect in amplitude. So that meant a completely different approach to the DSP core. And I did some calculations and worked out that I needed to have 104 bits as a DSP core rather than the 64 bits that people normally use. Went ahead, designed it, got the core working, got it listened to, and then ran my tests. And it worked perfectly at the minus 301 signal in terms of amplitude, but it actually still failed in terms of phase shift. So what I then had to do was to put noise shapers inside the DSP core so that every single node that the DSP was running to had its own individual noise shaper. And that noise shaping, when that was put into it, it then perfectly reproduced it. And we got the minus 301 dB phase shift as being zero phase shift. And of course, it sounded better once I put these noise shapers in as well.
So if I'm understanding you correctly, what you've done with the DSP inside the Mojo 2 isn't possible on a consumer-grade computer.
Absolutely. You just couldn't do it.
Right. Well, I know I guess it's obvious to you, but I guess to me and probably some of my listeners, because we obviously tend to think, MacBook or, whatever Windows computer, super powerful, it's just the most powerful thing you can buy, and therefore it should be able to do everything. And yet you've got a little Mojo 2 with DSP cores inside that can do what the MacBook or the Windows P cannot.
Exactly, yeah. And that's the benefit of running with FPGAs, because if you want to do a 104-bit filter, it's not easy, but it's possible to do it. You just create your own custom core. And in fact, one project I'm working on at the moment, that's actually running at 140 bits. And that is really scary, this particular project. I can't talk to you about what it is, but it's really scary. And I've been listening to the coefficients that went into this filter. And I ended up using 40 decimal point accuracy on the coefficients.
Okay, wow.
And that's just, incomprehensible that the ear could detect this level of performance. But it just illustrates that when you listen to things and certain things, you can hear extremely small effects going on. So I actually did the tests, and I did the tests under blind conditions with my son and said, listen to this and listen to that, because I thought I was losing my marbles when I was doing this. And he said, this one's got better depth and it's got better focus about it. That's what he said, which is exactly what I agreed. What I thought it sounded like myself. And so it's been, the last couple of years actually been really, really interesting in terms of what are the things I've been playing with.
Mm. I mean, you talk a lot about presumably soundstage depth, the depth of sound. Does that mean that most of your listening tests at home are done with loudspeakers?
Actually, most of the time I've been running with headphones. And if you'd asked me that question 4 years ago, I'd have said depth will be done on loudspeakers. But things have improved quite a lot with the DACs themselves and with headphones. And although I get better sensitivity and accuracy with loudspeakers, I can still hear it. And it's actually convenient because when you're listening on headphones, on closed-back headphones, it is completely silent. So, when the kids are downstairs making a lot of noise, you don't have to worry about that. So there's lots of benefits. And, of course, there are certain things that you can only perceive on headphones, such as inner detail, instrument separation and stuff. It's much easier to hear those effects on headphones. While I do my listening tests, I actually listen to lots of different things. So timbre variation is one of them. Instrument separation and focus is another. And then I've got tracks that will do just depth. And depth is something that I'm particularly fond of, or particularly see as an issue. So if you go into a cathedral and listen to an organ, and you're a couple of 100 feet away and listen to it, shut your eyes, it really sounds a couple of 100 feet away. But we certainly don't get anything like that with reproduced audio. And, my goal in life is to be able to get a realistic sense of depth from reproduced audio.
Do you have any sort of test tracks that you kind of, go-to test tracks, Rob, that you could share with us?
I can't tell you what they are at the moment because they're on my other computer.
Okay.
And I just don't remember. I've got 3 tracks that I particularly use that are good for depth. And I've listened to them thousands and thousands of times. So it's just, they're the ones that I get used for depth. And I've got a certain track for instrument separation and focus. I've got another track for instrument separation and focus and timbre variation. And, it's...
Are they all of the same kind of genre, or is it?
No, it's different.
Okay.
For depth, I've got an organ track, and I've got some electronic music. For the 2 other tracks are electronic music, which is actually pretty good for depth because they artificially encode it.
Yep.
Okay. One of the tracks is a guitar piece. The guy plays it at an incredibly fast rate, and it's really busy. So trying to hear each individual note being plucked, that's one of the tests that I use. One track from the Norah Jones actually is one of the ones that I use for timbre variation. They've got a nice double bass, so you sometimes listen to just the pitch of the double bass, and then her voice comes in, and that's something that's a track I've used for 15, 20 years. It's been a very long time I've been using that track.
Has it ruined it for you? Like, to just use it as a test track all this time? I can imagine it would.
Yeah, but I mean, when you're doing this professionally and doing a listening test, it's not about the music. It's just about the attributes to the music. The depth, instrument separation, the focus. What I then do, when I'm doing prototype work, and I'll make an improvement, and I've done the A/B tests and evaluated certain things. Then I'll just listen for pleasure, and then you'll use your emotional response to the music as an indicator of how much of an improvement you've made. But listening for the emotions is something that will take a week or so for you to get a feel of. But when you're trying to listen for depth perception, it's easy. Is something deeper or not deeper, and it's as simple as that. And you can easily tell whether it's better or not.
I guess we should talk about what you've done with this DSP, Rob.
Yeah, well, the factor with it was that what we wanted to do was to remove the coupling capacitor, which meant using a DC servo that I used in Hugo 2. Mm-hmm. So I've done that on Mojo 2. The downside to that is that you will lose some of the warmth that Mojo has was put into Mojo, and that slightly soft, warm sound. And now getting rid of the capacitor and removing that softness was something I wanted to do because it's going to make it fundamentally more transparent. But then you've got the situation, if you're using a bright headphone, how would you make it sound warmer and more natural? And that's why I thought, if I'm going to get rid of the coupling capacitor, we need to add EQ as a way of making people, deal with headphones that are cheaper headphones and are too bright or too aggressive or don't have enough bass. So that was why I decided to go for the EQ approach. And then, of course, the question became of how do you make EQ actually work? Because at the moment it doesn't work.
What do you mean by it doesn't work?
It doesn't work in terms of transparency.
Okay.
In that when you change the EQ, you can hear degradations in sound quality. So I needed something that was completely transparent. We've called it lossless DSP. And so that you could actually adjust the bass. You could actually make it sound warmer or make it sound brighter or more incisive if you wanted to, without it degrading the musicality or degrading the transparency.
So you're using the word lossless here to describe there being no loss in sound quality, I suppose. Right, yes, transparency, basically. Right. Yeah, okay. Because, I've had a listen to Mojo 2, and I think for me, it's more lively, more microdynamically lively, that the smaller stuff pops more.
You should have noticed two things. One, the bass is a lot tighter and more defined, and the soundstage and the detail resolution was much better. The soundstage and the detail resolution was down to the improvements in the noise shaper. So I want to backtrack and explain why I've done that. The problem we had with the original Mojo, or the problem I had with the original Mojo, was power dissipation. And with something that small, you've got a power limit. And you've got a power limit whilst charging it. You've got a power limit whilst you're listening to the music. And it meant that I had to throttle back on the performance of the FPGA because it would just get too hot. So what I wanted to do with Mojo 2 and what I've done with Mojo 2 was to enable the FPGA to run at full capacity rather than the limited capacity before. To do that, I had to save 200 milliwatts from the design because I'm putting 200 milliwatts into the FPGA. So there's 200 milliwatts more power being generated in the FPGA. That meant I had to save 200 milliwatts from other parts of the circuit. And I managed to find out where I could make those savings without it sacrificing performance at all. There are little things like the way the relay was working, the way the efficiency of different circuits was working, and that got me the 200 milliwatts. So now I've got an extra 200 milliwatts worth of power. I can do several things. One, I can add the digital DC servo to get rid of the capacitor. The other thing is I can improve the WTA filter, which is what we've done. And the third thing was to improve the noise shaper. And of course, to add the DSP core for the EQ, because all of these things are quite intensive. The benefit of improving the noise shaper was that you get better depth and detail resolution, and that's how you can hear it as sounding, more sharper and more precise, because you've got that better detail resolution. You should have heard that the depth was significantly better as well.
So with the EQ, you've got 4 bands. Do you know off the top of your head what they are? Because I don't actually. Because
what you've got a 20 and it's certainly on the handbook. Maybe they haven't published the handbook yet.
Right.
There's a 20 hertz peak filter, so you can increase by up to 9 dB or cut by 9 dB at 20 hertz.
Okay.
You've got a 20 kilohertz peak filter, which again, plus 9 dB or minus 9 dB. Then you've got a broad shelf, which means that from 125 hertz right down to DC, you can boost it by 9 dB or you can cut it by 9 dB. And then there's another one for the treble, a treble shelf, 3 kilohertz right up to 20 kilohertz. You can increase it or decrease it. So you've got control over treble, you've got control over the mid-range and the bass, and you've got control of the extreme treble and extreme bass.
So the second two that you mentioned, what we loosely call the mid-range bass and the treble, the Q on those is wider?
Right. So the peak filter, that's got a Q, and that's set to 0.5. Mm-hmm. The reason I set to 0.5 was it meant that 20 hertz, if you set the 20 hertz to plus 6 dB, then at 40 hertz, it'll be plus 3 dB. So it's following a first order characteristic.
Right.
The shelf filter, when you do the calculations for a shelf filter, it doesn't have Q. It's not the way that the biquad filter works.
Okay.
It's just a fixed slope, and it's designed to be as sharp as you get for a biquad implementation.
Okay, so the different kinds of filters within your... Right.
You've got a conventional peak filter for the 20 hertz and the 20 kilohertz, and you've got a shelf filter for your bass and for your treble. What I wanted to do was that I looked at a whole load of headphone frequency response plots of that was available, and I could see some of the Japanese headphones were bloody awful. The mass market Japanese, they start rolling off at 125 hertz, and it's 6 dB per octave at 100 hertz, and it's just dropping down to nothing at all. And a lot of Japanese mass market products are built that way. So I wanted to be able to have the option of dealing with that, which you can do with the bass and the bass peak. Mm-hmm. So you can certainly sort out your low frequency problems. High-end headphones are pretty much flat, and the Japanese high-end headphones are pretty much flat as well. It's just the mass market mainstream products that are pretty awful. And then, of course, on the treble side, that's really there to make it sound warmer or to get rid of sibilance problems. And if you've got a sibilance problem, you can just drop the shelf down by 2 or 3 dB. And if you want to restore the 20 kilohertz, you could just boost that up again by, say, plus 3 dB, and that will give you a nice suck out between 3 kilohertz and 10 kilohertz.
Is there a way to EQ Mojo 2 to sound more like the original?
Yeah, just do the shelf by a couple of dB and the 20 hertz by 1 dB or so, and that'll make it sound warmer and softer.
Huh. Okay, that's good to know, because some people might be very attached to that original sound, and if they know, right?
Exactly.
Right.
That's the reason I put the EQ in.
Right.
And we often get situations. You'll watch the forums. And the great thing about forums is that you really get to see how people use your products. And that's not something that we used to be aware of 20 years ago, because you'd launch a product and then you maybe get some reaction a couple of years later from somebody at a show, and they wouldn't say very much. But now, today, you launch a product, within 2 days, people are buying it and playing with it and putting their comments on. And one of the things you notice is that 1 minute someone will be buying a Mojo and saying, it's way too bright. Next minute, someone will be buying a Mojo and saying, it's way too soft and warm. And I've often wanted to be able to offer real ways of fine-tuning the sound to suit your own particular tastes without it damaging the sound quality. And of course, conventional analog tone controls seriously degrade the performance, and digital DSP degrades the performance. So the beauty of this approach is that you can play with the frequency response without it damaging the transparency.
Is any of your sort of EQ work informed by the Harman curve at all?
No.
Okay. Because I do find a lot more people talking about that nowadays, and I think it's
and I
fascinating.
think that's completely appropriate for a headphone manufacturer. That makes complete sense. But no, we're not. I'm not. It's not about that.
Okay.
The frequency response curves that informed me on how to do the DSP was really about the straightforward frequency response, and in particular the low frequencies. The DSP that we've got will tune out low frequency problems. It's not going to do a great deal for, if you've got a resonance at 9.52 kilohertz, there's nothing that this EQ will do anything for. You could, it's a broad brushstroke worth of approach, so that you can just tweak the sound to suit rather than specifically trying to get rid of individual resonances.
I mean, I guess the wonderful thing about putting an EQ into a product like this is it takes any potential criticisms that you've just outlined off the table. Because if somebody says, "Oh, it's too bright," well, you go, "Well, dude, you can do something about that, right?
You can tweak it."
Yes.
Yeah, it's gonna be fascinating to see how people deal with this, it's going to be fun.
I mean, do you anticipate people? I guess people like me who generally use the Mojo in a loudspeaker system, probably more than well, it depends, but I do use it a lot in a loudspeaker system. For example, I might have a pair of speakers that I might think is a little bit too lively in the treble. Do you anticipate people using the EQ for those kinds of situations?
Absolutely, yes. Yeah, I mean, not all of us are in the situation where we're really, really happy with the sound of our loudspeakers. And I happen to be really happy with the sound of loudspeakers in my room. And I don't need EQ for that, but I certainly could do with it for the headphones. Particularly headphones, even if they're a flat response, follow the Harman curve or whatever, they're still a little bit brighter than the sound that you get from loudspeakers. Now, perhaps loudspeakers just artificially enhance the sound, give you more bass than headphones, and headphones are the true number. But then when I listen to live, unamplified music, things sound a lot warmer than they do when you hear it through loudspeakers. And loudspeakers seem to be closer in tonal balance to the sound of real music.
Interesting. You've also done something else with the EQ, Rob, you've implemented crossfeed.
Yeah, well, once you've decided to put in a DSP core, putting in crossfeed was no cost in terms of gate count. And it's gate count that's the issue with Mojo, and power supply dissipation. So I really love crossfeed. I couldn't exist with headphones without crossfeed, because it just makes things sound so much better. And I know that some people barely hear a difference with crossfeed, and some people feel like me that it's absolutely essential. So I'm pretty pleased that we managed to put the crossfeed in.
Is it borrowed from? There's one in the Hugo 2, isn't there?
It's exactly the same as all the crossfeed implementations. Dave, Hugo 2, Hugo 1, the formula, characteristics for it are identical. The coefficient numbers are the same. And, the 4 different settings for it are the same. The implementation, of course, is different because it's done through the DSP through biquads, rather than with Hugo 2, it was an individual DSP, serial DSP core that I designed to do that function. So the implementation is different, but the mathematics, the coefficients are the same.
Gotcha. Okay. And you have quite a celebrity user of Mojo in Neil Young.
Yes. Yeah.
Right, because he's quite a vocal proponent of Mojo, and
yes.
Yeah, I think that's wonderful for you. And that happened, from what I understand, talking to Dan, your Chord's PR guy, is that it wasn't Chord courting Neil Young. It was Neil Young phoning up Chord and going, "Hey, I love your DAC."
Yeah, we get that quite a lot with pro people. And, they hear the products. We've got a lot of mastering engineers using Dave's. And I'm constantly being nagged about in terms of the A to D converter for when that's going to become available. Whenever I do shows, a pro guy will come up to me and say, "Well, come on, when's this thing going to be finished?"
Right. I guess Because you've been working on that for some years, from what I remember, right?
Yeah. It's the trouble is it's not been a number one priority project. It's been a background project, and the trouble with background projects is that they tend to get put to one side because you've got other important things that need to be finished. So, and of course, commercially, it's not as important as, say, for example, a Mojo 2. But it's very much a long-term project. But it's something I'm actually working on today. So,
right, okay,
that's another story.
So I guess you've always got sort of R&D going on in the background, no matter what the product.
Yeah. I mean, 4 years development time for Mojo 2 is not untypical, but it's long. Well, it is a little bit untypical. It's normally about 2 to 3 years to develop a product, but of course that time is just from when the PCBs were first shipped out to today. When I was starting to think about the project, and you don't record in terms of time when you think about projects. That pretty much started as soon as you finished one project, you start thinking about what I'm going to do next. What would I like to do to improve on this? But that's another situation. And I was thinking of that as soon as I finished Mojo. I was thinking, right, what would I like to do for a Mojo 2? You just start to get your juices flowing in terms of thinking about various things.
Yeah, right. I guess it's never a dull moment at the Watts household.
Well, dull for everybody else. It's not dull for me.
Right. Well, I really appreciate you taking the time to talk to us today, Rob. It's been most illuminating.
It's been a pleasure.
I know there's always a sort of technical nitty-gritty that you want to get into about a new product, and I hope we've covered some of it today. I'm sure there'll be questions that I missed. I'm sure there will be, but do you have any last words, Rob Watts?
No, I think I've confused people enough.
Well, thank you so much.
My pleasure. Thank you very much.
The Darko Audio podcast is produced by Nick McCorriston. Music comes from Ben Pitt.